Problem 3 of simple band brake. Example 6.37. A simple band brake has a drum diameter 500 mm and the vertical passes through the center of drum, also passes through the fulcrum is 350 mm below the center of drum. The length of brake lever is 800 mm. One end of the brake lever is attached to the brake lever at a distance of 250 mm to the fulcrum, and the other end is attached to the fulcrum. Power absorbed with 30 kW and a speed of 1000 rpm. See rating suitable materials, assuming approved value for vector safety. Determine dimensions of the rectangle cross section of the brake lever, assuming the depth is twice the width. Dimension of the rectangular cross section of the band, assuming the width is 10 times the depth. Now given things are: D equals to 500 mm, R is 250 mm, power is 30 kW, N is 1000 rpm, H1 is 2 times of B1, W is 10 times of W. So here you can see that there is, so the theta angle of lap is not given, the angle of lap is missing, but they have given the figure. So this is the given figure. They have said that the brake drum is 500 mm, brake drum is 500, and the distance from the brake drum center to the fulcrum is 350 mm, and this is B. From here to here is B, and from here to here is called the brake lever length, that is A. These two are given. Now how to find theta? So to find theta, let us assume, so this is so they have said this is let us assume this is A. So now the triangle, now to find theta, so this becomes a radius, that is O1A is 250 and O1O is 350. It's already given. And triangle O1A OA, triangle O1OA is a right angle triangle. So the hypotenuse, so OA equals square root of O1 square minus O1A square. So therefore we get OA as 244.95 mm. Now you have to find the angle pi. So angle pi is OA upon O1A, opposite by hypotenuse. So O1A is 244, just now we found this, and hypotenuse is 350. It's already given. Therefore we get the angle pi as 44.115 degrees. So we get this pi as 44.115 degrees. As you can see that this one is straight, so angle of overlap will start from here. This is 180 plus, so this 90, so this 90 minus this pi 44.15 we get, so 90 minus 44.15, so this will be that angle theta. So after finding the angle theta, next move on to the procedure. So the torque transmitted the same procedure. Empty is alpha is 0,000 N by N. So we get empty as, so we get the empty as 2865000 Newton mm. Now using this empty, so empty formula, empty is F theta and R to find the actuating force. So therefore F theta equals to 1146 newtons. So now to find the actuating force F, so from the detailed book, that is 19.8 table 19.1. So we have these two formulas, figure B. So we have these two formulas. After these two formulas, using both the formulas, find both F. Or to find both F, substitute the values of F theta, B, A, e to the mod mu theta. So find both F and choose maximum one. So substitute the values of F theta, B, A, 1 upon e to the power mu, that is 0.3, theta 0.3. If it is not given, assume it as 0.3. And theta is just now we found 225.6 or 225.85 into pi by 180 minus 1. So we get 1F for clockwise, for counterclockwise formula we get as 517. So the maximum of these two is 516 Newton, 70 Newton. Now to find the width, now design of lever. So design of lever, since they have not given the allowable stress in the lever, so we can assume it as C40 steel and Fs of 3. So for C40 steel, sigma y is 328.6 sigma. Therefore the allowable stress sigma B is equals to sigma y yield stress upon Fs, so that we get as 109.53. So we get 109.53. Now So bending equation m by I sigma b upon c. I is b1 h1 cube by 12. Since h1 is twice the b1, since it's given the problem, it's already said that depth, so depth is twice the width. That's why h is twice the width, that is 2 b1 cube by 12. So we get it as 2 by 3. Simplifying this, we get 2 by 3 b1 4. So c is h by 2 or b2 by 2, that is we get b1. Now substituting the values of sigma b f max into a, f max is 516 into a length is a brake arm lever 800, we get this much bending moment. Substituting the values of bending moment in the bending equation. Bending moment I is this, substituting here. Sigma is 109, substitute it here. And c, instead of c, substitute b1. Therefore we get b1 as 17.82 mm, or we can round it to 18 mm. The thickness of the brake lever will be twice the width, which is twice the width, that is 36 mm. Now dimensions of the rectangle cross section. Since any of the dimensions is not given, there is no hint of h, or neither there is a hint of w, so we can, the thickness of the band we can assume from the table number on equation number 19.160. If any of this if is not given, so use the equation 19.160. H equals to 0.005 d, that is 2.5, w equals to 10 into h, that is 25 mm. So this was about the to find angle of theta and the design of lever.